Okay, so here we are doing an investigation of exponents on I. We have to start with knowing that I is I, and that I squared is negative 1, and that I cubed is negative I, and that I to the fourth is I. With your investigation that you did for homework, you realized that this is going to be consistently repeated on and on and on and on if we were to keep going in a consecutive order down this way. But how can we use this information here to come up with any exponent's answer or the result for any exponent on I? So let's remember our exponent rules. Remember our exponent rules. X squared times x to the third equals x to the fifth. So if I'm multiplying the same base number with different exponents, I add the exponents. However, if I take x squared and take it to the third power, I have x to the sixth. Do you remember that? So these are two basic rules that we have to know in order to do this investigation. If I look at I to the fifth, I already know that it's going to be I because you guys have discovered that this pattern is going to continue. But how can we really prove that? How can we use that as information? Well, what I can do is I can break I to the fifth up into I to the fourth times I, because I to the fourth times I to that invisible 1 is going to give me I to the fifth because of this rule. So, well, what is I to the fourth? I to the fourth equals 1. We just figured that out. And so what is 1 times I? 1 times I is I. Now I have I to the sixth. And the reason why I'm sticking with I to the sixth and I'm not breaking it up at all is because if you did this whole investigation and you saw that there was some kind of pattern going on, all even exponents will yield a negative 1 or a positive 1. So we have to just figure out, well, which even exponents yield a negative 1 and which even exponents yield a positive 1. Well, the special even exponent that yields a positive 1 is the exponent whose is divisible by 4. If the exponent is divisible by 4, the result will equal 1. And again, it's really just because we found this pattern going on, okay? So if I was to go back here and rewrite it, now all exponents that are not divisible by 4 but are even will yield a negative 1. So this is kind of like a pattern that we can memorize, or we can try to, work out how we can figure this out. So I to the sixth is negative 1. And now how are we going to get I to the seventh? Well, you already know, like you just said, you already know that this pattern is being repeated, so it's got to be to the negative I. But let's talk about why that is. Because what is another way to write I to the seventh? According to this law, right up here, I can write it as I to the sixth times I. And I already know what I to the sixth is. Because it's an even exponent that's not divisible by 4, I to the sixth is negative 1. And what is negative 1 times I? Well, it's negative I. And then I have I to the eighth. And 8 is divisible by 4, so this must yield a positive 1. Now, how can I use this to get to and this is just for your brain and to investigate and to see patterns and to use patterns. What if I asked you to find I to the 15th? How could I break I to the 15th up such that I'm either going to have a 1 or a negative 1 as part of my product? So I'm going to have I to the 14th times I. What is I to the 14th? Is the exponent divisible by 4? No. So that means I to the 14th must equal negative 1. And negative 1 times I is negative I. I'm going to do a few more of these, and then I'm going to ask you to do some on your own. What about I to the 20th? Well, I don't even have to rewrite it as using different rules, because I know that I to the 20th, 20 is divisible by 4, so I to the 20th is going to equal 1. What about I to the 77th? How can I rewrite I to the 77th? I simply go through here and I write I to the 76th times I. Because again, because of this rule up here, I to the 76th times I is I to the 77th. Well, what is I to the 76th? Is 76 divisible by 4? Do it in your calculator. Is it divisible by 4? Yes, it is divisible by 4. Okay, so I to the 76th is going to equal 1, and 1 times I equals I. Now I want you to try a few more of these. I, just for fun, now these are very silly numbers and you're never going to use them, but this is just a great opportunity to just practice the skill. I to the 313, I to the 207, I to the 156, I to the 288, and last, I to something really ridiculous and silly, 1,711. You try those. Oops, there they are. You try those, and then come back, and this will be the second video, the answers to this.